Hello and welcome. In this video, we're going to be starting a new series similar to the hardest M1 questions. However, this series is going to be the hardest pure questions from the past papers to help you guys tackle the A and A star level questions. We're going to be starting by solving the Cambridge 9709 paper 12 May-June 23. 9709 paper 12. This is the question that we're going to solve today, and please, if you have any questions you'd like me to solve, leave them down in the comment section below and I will solve them. So let's start by reading the question. We have a diagram, and the question says the diagram shows a sector OAB. So this whole thing is a sector, and it looks like it's divided into two regions. The sector has a center O and an angle theta in radians. Take a note that we will be dealing with radians over here, so make sure to have your calculator set to radians. It says that OP and AP are equal and they are given the value x. Part A says show that the arc length AB is 2x theta cosine theta. Okay, so I'm basically required to get this arc length. So to get something, we need to know its formula. So very simply, the arc length formula goes like this. It's going to be, we're talking in radians here, so it's going to be the angle of the sector, which is this angle, over 2 pi multiply the circumference of the circle, which is 2 pi r. Okay, so this is going to be the arc length. We can further simplify it. 2 pi are going to cancel, so we're going to have basically theta times r. Theta is already given. Okay, it's given a value of theta. We don't need to do anything over here. However, the radius, we need to find the radius in order to solve for the arc length. So the radius is basically OA, apologies, or OB. These are the radius of the sector. Okay, so we can get any of them. If we take a look, we have this triangle. Okay, so it makes sense to maybe start looking at OA, because OB is a little bit difficult. There is nothing I can see that will help me get this part and then add it to x. So let me start by looking at OA. I see that this is an isosceles triangle. How do I know? Because I have two similar sides. Okay, so two similar sides, so this angle and this angle are going to be equal, because this side is opposite to this angle and this side is opposite to this angle. So the equal angles are going to be opposite to the equal sides, leaving this angle to be the different angle and this side to be the different side. Okay, so basically we're trying to find OA. Let's see how we can find it. First of all, I know that this is theta, so this is going to be theta. And then knowing that the sum of angles in a triangle add up to 180, I know that this is going to be, now we're talking about radians, so we're gonna have the sum of the angles add up to pi, not 180. So pi minus these two angles are going to give me this angle, so pi minus 2 theta. This is this angle over here. So what I've done is, there is multiple ways, okay, but I'm going to show you the way that I instantly thought of, okay? And if you have an easier way, send it in the comments down below. I thought about the sine rule, okay, because I have this angle and I have the side opposite to it. I have this angle and I want this side. So I thought about the sine rule. So let's see how we can use it. The sine rule goes like this. This side, x, over sine of the angle opposite to it, so sine, the angle opposite to x is theta, so sine theta, is going to equal to this side, which is basically OA, over sine the angle opposite to it, so sine pi minus 2 theta. Okay? So over here, if I want to find OA, it's basically going to be x, I'm going to multiply this over there, so x times sine pi minus 2 theta over sine theta, and this is going to give me OA. Now I have to simplify to make this similar to no, this is the radius still. I just have to simplify. Type here requires some trigonometry information, okay, or trigonometric identities knowledge. So I know that sine of pi minus any angle is basically equal to sine that angle, and you can try in the calculator. Okay, so basically this is going to equal x times sine 2 theta over sine theta. Now from here, let me try and play with this 2 theta. I know that sine 2 theta, this is a double angle identity, so I know that sine 2 theta is going to equal 2 times sine theta times cosine theta. So I can change this to become x times 2 sine theta cosine theta, and I think from here you know how we can reach the required destination. So over here sine theta and sine theta will cancel, leaving me with 2 times x times cosine theta, which is basically very similar to this one. So all I can say for these identities is just practice. And practice is what's going to make you tackle these questions correctly. Okay, now let's go to the harder part of this question. So part B says find the area of the shaded region. Let me just erase some. Think about it. The shaded region over here is basically, I can break it down into the big sector area and then this small triangle area. If I subtract the small triangle from the big sector, I'll be left with this shaded area, which is what I need. So this is what I'm going to try to do. I'm going to get the area of the big sector and then the area of the small triangle, subtract them from each other to end up with this shaded region. So let's start by getting the area of sector. So the area of sector is basically theta over 2 pi, so theta over 2 pi multiply pi times the radius squared, and the radius we already got, which was 2x cosine theta, so this multiply 2x cosine theta all squared. So now I can see that pi and pi will cancel, and I will have theta over 2 multiply. Let me distribute this squared to everything, so this is going to be 4x squared cosine squared theta. 4 and 2 can cancel, and this is going to give me 2x squared cosine squared of theta. So now let me, okay, I'll just leave it. So this is basically the area of the sector. Sorry, this is, I forgot this theta. So this is just 2 times theta x squared cosine squared of theta. Now, the area of triangle. Yeah. So the area of a triangle, I know that if I have two sides, let's say OA and OP, and the angle between them, I can find the area of the triangle using this equation, this formula, half AB, half of the first side times the second side, multiply sine the angle in between them. So this is what I'm going to use over here. So the area of the triangle is going to be half times the first side, which is OA, which I got as 2x cosine theta, multiply the second side, which is basically x, multiply sine the angle between them, and the angle between them is basically just theta. So let me simplify a little bit. This is going to cancel. X times x is basically x squared cosine theta sine theta. So this is the area of the triangle. Let me now do area of sector minus area of triangle to give me the area of the shaded region. So this is going to be area of sector, which is 2 theta x squared cosine squared theta minus the area of the triangle, which is x squared cos theta sine theta. From here, let's see if I can take anything out common. I can see that I have an x squared here and x squared here. I have a cosine theta and I have a cosine theta. So this is what I'm going to take out common. So I'm going to take x squared cosine theta outside. Now I'm going to be left with, I'm going to remove x squared and 1 cosine theta from here. So I'm going to be left with 2 theta, x squared is gone, and we will take 1 out of those 2 cosine theta. So I'm just going to be ending up with cosine theta. And then minus, which is this minus, I'm going to take an x squared and a cosine theta. So I'm just going to be left with sine theta. So the final answer is going to be x squared cosine theta times 2 theta cosine theta minus sine theta. And this is going to be the area of the shaded region in terms of x and theta. We don't have anything else except of x and theta. And this is as simple as it can get. This is a starting question to the series. We're just gonna get things kicking up. Lots of more difficult questions are coming. So please don't forget to subscribe, like, and comment your thoughts and your questions down below. I'm gonna read all of them. I'm gonna try help as much as I can. And yeah, see you in the next one. Stay tuned and thank you for watching. Have a good day.